proofs. It begins on page 151, and there's a big chart, so you need to make sure you're able to see that and open it up as big as you can. Okay, on that chart, there are several things that you're going to need. These are the building blocks for all of our algebraic proofs. Algebraic proofs are the easiest of the proofs. Okay, these are properties that we used a lot in Algebra 1. Okay, we use them in, we probably even used them in 7th and 8th grade. We just didn't call them anything. So I'm just going to remind you of what they are. The addition property of equality is just when I say add to both sides, that's the addition property of equality. Okay, so now we have a name for it. We've had that name in Algebra 1, but you may have forgotten after we started going further and not using it anymore. Then we have subtraction property of equality. That's when we subtract something from both sides. Multiplication property of equality. Division property of equality. That's also where we multiply to both sides, divide by both sides. Okay, so these are all properties that we've all used before and we've seen before. We just have to remember to name them now. I told you guys last year that we can use POE or PO. So you may remember addition PO, subtraction PO, multiplication PO, division PO. Okay, you can still use that POE. I don't mind. Just you have to know what it stands for. It's property of equality. Okay, moving down to the symmetric property of equality. This is ones that y'all guys may have seen before, but you probably do not recall. It just means that I can flip-flop something. If I say x is equal to 5, then that also means that 5 is equal to x. It just flip-flops it. Okay, so here they say a is equal to b, and b is equal to a. It's all the same. Okay, so, or sorry, did I say reflexive? Oh, I'm sorry. I meant symmetric. Symmetric. So, say again. They're close. They are very similar, but they're not the same now. Symmetric is where I have the same thing no matter how I turn it. So, like if I'm trying to use a good example here. Okay, our bodies are symmetric. So if I split myself down the middle, for the most part, they're symmetric, right? I have one eye on one side, one eye on the other side, half of my lip, hopefully, right? Half of my lip matches the other half of my lip, chin, ears, all that stuff. So basically all that means is if I flip-flopped everything, right, if I completely reversed it and put it on the other side, it would still look the same in essence. Now the reflexive property is more responsive to mirrors. So it's literally if I threw something straight down the middle like that, it would exactly mirror itself. A is equal to A. Okay, so it's reflexive property is just saying something is equal to itself. So if you get something like 9 equals 9, or we'll see it a lot with like side lengths. So on reflexive property, we'll see a drawing of a picture that looks like this, and it has this side length. Say it's AB. So sometimes we say AB is equal to AB, and why we would say that is to prove that something is congruent. But when we say that this is equal to that, we have to state why it is equal to that, and that's the symmetric property of equality. It tends to be because two shapes share the same side. So for instance, this rectangle and that rectangle share the side length AB. So when we state that they are the same side length, not just the same labels in different shapes, we have to state that they are reflexive property that allows us to do that. Next one is the transitive property. I've talked about this one a little bit already. This is saying if Call has 5 candy bars and Jada has as many as Call and Lacey has as many as Jada, then how many does Lacey have? 5, right? The reflexive property is basically just a transition down the line, saying if one thing is equal to another and that other thing is equal to something else, then the first original thing and that something else are also equal to each other. Okay? So in their example, they say A is equal to B, B is equal to C, then A must be equal to C. Notice that the middles match up. Okay? This should remind you of one of those two properties, detachment or syllogism. Does anybody remember? Syllogism. Okay. Next one is substitution property of equality. It's just when I sub something in. Okay, so if I say x is equal to 3 and we sub in 3 for x, then that is a substitution. That means substitution property of equality, right, Nick? Stop making googly eyes back there. Okay, flip your page. We're going to example 3, the very first example that we're going to get to do, or sorry, example 1. My bad. Example 1 says writing an algebraic proof, and then it gives us a sample equation. We did this in Algebra 1, so this should be really easy for you. 2 open parentheses x plus 1 close parentheses equals x plus 9. Okay? So yes, what Maria just said is distribute, but I'm going to set this up. This is called a 2-column proof. Okay? So all I do is I draw a line straight down the middle, I work it right here, and I explain it on the right. So this is what it'll look like. You'll say statement, and then reason on the right. Now the reason we have this written down is because it was given to us, so we're going to write down given. Most proofs start with a given, so get used to that. Next, we're going to follow what Maria said. We need to distribute, right? So we already know what our reasoning is. It's the distributive property. That's relatively simple, but now we just have to do it. So we get 2x plus 2 equals x plus 9. And that's a distributive property. You can abbreviate property. There's a few things that I don't want you to abbreviate. Don't abbreviate the associative property for obvious reasons. Don't abbreviate, there's another one that's, when we get to it, I'll address it. I'm trying to remember the name of it. Dang it. Okay, anyways, what's the next step in solving this? What do I need to do? I need to move the x, right? I need to move all my variables to one side and all my numbers to the other. So I'm going to move my x. So I subtracted x to both sides. What property allows me to do that? The subtraction property of equality, right? Okay, and then I just simplify it after that. So I'm left with just x plus 2 equals 9. What's the next property that I need to use? I subtract 2, and what is that property called? Subtraction, property of equality. Yes. Are you saying could I subtract x and subtract 2 in the same thing? At the same time? Yes, do those 2 steps in one? Yeah. Yes, we could. If it didn't ask us, like if you were doing this in just a regular problem instead of having to explain your steps as you go, yes, I would say go ahead and do it, I don't care. But when we're explaining our steps step by step, we have to do them step by step. Maria? This 2 right here? Yes. We distributed this 2 to that 1 right there. So when it's 2 times 1 is 2. Is that what you're at? Oh, sorry, I didn't point at it. 2 times 1 is 2.
I know that's what it was.
Oh, okay.
Pictures in the menu.
Okay, so 2 times x is that x. Is that what you're asking me? Is where this equation came from? Okay, from here, all I have to do is write simplify at the end, and that's it. Simplify. Any questions then? The next step in that, if you were actually solving the problem, would be to check your answer and make sure that you're not wrong, right? So just plug it back in and check it. But as for the actual algebraic proof, this is it right here. Okay, that is all. Any questions on the algebraic proof? You guys have all seen this before, hopefully, so shouldn't be anything new to you. So that was part A. That was example A, I mean. Example B asks us to solve a completely different one. It gives us 3x minus 1 over 5 and sets it equal to 2x plus 3 over 3. And again, I'm going to set this up in a 2-column proof. I'm going to have a statements and reasons column. Okay, this was given to me, so I'm writing that down first. It's given. Now, there is a certain way to solve this that y'all guys probably already know. And then there's another way to solve this. This is a way that y'all probably don't know. So I'm going to ask you, how would you solve it first? What would you want to do? That's an Algebra 2 skill, so probably not. But yes, that's the one that they don't know, Tanya. That is the one that they don't know. So what I've taught y'all guys to do is do cross multiplication, right? So that's how I would expect you to solve this, is do your cross products. There is another way to do this, and Tanya started to explain it. She said multiply it by what? The denominators, but it's looking for the least common multiple of the denominators, right? What is the least common denominator? It's 15, right? So we could multiply this entire thing by 15, which would be multiplication property of equality, and that would simplify it for us. Or we could do cross product, and I prefer cross product. It's way easier. So I'm going to say let's do cross product, okay? So what we're doing, I'm just going to rewrite it. It's 5 times 2x plus 3, so 5 multiplied by 2x plus 3 in parentheses, and then 3 multiplied by 3x minus 1 in parentheses. So I have a new thing. Now what property allows me to do that? It's I hate to give it an improper name because I don't remember the actual name of it, but we're just going to call it the cross product property of equality. Last year I seen a bunch of people getting crazy with the property of equality. They were throwing it at the end of everything. So don't do that. I've seen like reflexive property of equality, and they throw them all sideways. Okay, we just need to use it where it's appropriate. So sometimes we may need to use reflexive property of equality, but when they're asking just to state the property, you don't have to fully spell it out. All right. So from here, I want to do what? Distribute, right? Plus 15 equals
Split
9x minus 3, right? So I've distributed everything. I use the distributive property. And I've seen the distributive property of equality too. That's not even a thing. Just a distributive property. That's all we used. Now I have to solve. I need my variables on one side and my numbers on the other. So I'm going to subtract 9x. What property allows me to do that? Subtraction property of equality. So subtraction property of equality. And then I need to move what? The 15. So I subtract it again. What property did I use to do that? Again, the subtraction property of equality. I should have put that up here. That goes to this step. Subtraction property of equality. And then what is the last thing I do? Simplify. Yep. Okay. Questions? Okay, those are the easiest ones. So the next part is we're just going to learn how to verify an algebraic proof. So example 2 is just that. We're going to verify algebraic reasoning, in other words. So on example 2, it says the steps of an algebraic proof for solving the equation 2 open parentheses a plus 1 close parentheses equals 6 are given below in the correct order. However, the justifications for each step are out of order. Determine the correct order for the justification. So here's our example. Okay. So I'm going to ignore this side for the time being, and I'm just going to simply follow what they did. What is the first step in solving this? I distribute, right? So they use the distributive property of equality. So they're good so far. Next, they had to do what? What happened next? They subtracted 2 from both sides. So what is that property called? Subtraction property of equality. Boom, boom. Then next they had to do what? They divided by 2 to each side. So what is that called? The division property of equality. Proper terminology here. Don't say the dividing property of equality. And then lastly we simplify. Okay, so the only ones that they got confused were these two right here. They just need to switch them. So in my reasoning I would either say oh look at this, the given needs to be at the very first, right? The simplify needs to be in this category too. So I would say that we need to switch the given and simplify, and we need to switch the division property of equality and the subtraction property of equality. And then I'd write them in the order that they need to be in. So go given, distributive property, subtraction property of equality, simplify, division property of equality, and then simplify again. Okay? These ones are easy, but if y'all guys look at them too much on the wrong side, you'll get confused. So try to just go through here and go, okay, what did they do? 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 Okay? And then if you need to, look at your options. Any questions there? On example 3, finding dimensions, you will start that proofing process with something a little bit different. So be careful when you start this. Example 3 gives us the area of a rectangular patio is 28 feet squared. Okay, the patio's length, so length is 3x plus 1. And its width is 2x. This is in feet, right? Find the dimensions of the patio and provide a justification for each step. Now this is where a lot of you are going to start to struggle because we did this practice and many of you were absent. We got to do this again. So to begin our proof, we have to state all of this. Okay, the area is 28 feet squared. The length is 3x plus 1. The width is 2x. And then we start putting it together. Okay, so we're going to start with the area equals the length multiplied by the width. That is the area. The formula for area. Formula area of a rectangle or a quadrilateral or whatever shape we're dealing with. Okay, questions right there. Is there anything that we need to go over again? Okay, so starting there, you should just be able to plug in, and this would be called the substitution property of equality, because area is 28. I'm going to write that in. 28 equals my length, which is 3x plus 1, putting it in parentheses, multiplied by my width, which was 2x. So I use substitution here. And that is another property of equality. Now, I need to start solving this. How can I do that? What's the first step, guys? What Marie tried to say was distribute. So I'm just going to drop down my 28. I can't do anything with that right now. I'm going to distribute my 2x. 2x times 3x is 6x squared. Any questions there? Next, I need to distribute it out to my 1, which is just 2x. And then I need to justify my reasoning, which is distributive property. Now I start my justification process. I'm going to try to simplify this as much as I can. And I notice when I look through here that it has a common factor of, anybody? Looking at each of these terms, 28 even, 6 even, 2 even. Common factor of what? I heard somebody say it, not very loudly. 2. Has a common factor of 2. That means I can get rid of or make this smaller by division of 2. So I'm just going to go ahead and divide everything by 2. So the reason I can do this is called the division property of equality. Okay, when I divide everything by 2, I get 14 equals 3x squared plus x. So 2 divided by 2 is just 1. So 1 times x is x. Now I have a smaller equation. That just helped me out a little bit with dealing with the next couple of steps. So this is where I'm afraid that I might lose you guys because we're not highly practiced on this. So just bear with me and then we'll see if we can mudge through this, okay? I'm going to subtract 14. I have to have, in order to solve a quadratic, which is what this is, I have to subtract 14. So I'm subtracting 14 from both sides. Okay? 14 minus 14 is 0. And I'm left with 3x squared plus x minus 14. Okay? So what I did was subtraction property of equality. And some of you are probably asking, why did I subtract that? Hopefully this will make sense on the next step. I'm going to start with what I know. I know that I have to set up 2 sets of parentheses to factor in a quadratic. Quadratics are just x squareds, okay? Things with x squared or something squared in them. And then I look at my backside. I notice that's a negative, so I have different sign difference. That means I'm going to have a plus and a minus inside of my parenthesis. Then I look at my a, remembering that these are supposed to be in the form ax squared plus bx plus c. Okay, so I'm looking at A, which is 3 in this case, and I try to remember what factors there are of 3. There are only 2 factors of 3. What are they? 1 and 3, right? So, and I factor out x squared, which is x and x, right? So I have 3x on one side and just regular x on the other side. I have to keep in mind that this plus could go here and this minus could go here. I just don't know where they're going to go yet. I'll figure that out in the end. But I do know they're going to be different signs. Next, I need factors of 14. Okay, so let's start looking at factors. I'm going to factor it out over here. So factors of 14, I get 1, 14, 2, 7, and what? Anything else? That's it, right? Okay, so I factored out 14. We know the factors of 3. They are 3 and 1. And then I will also need to look at what's going to happen in my middle. This is a horrible example to start you out on. So in order to find out what happens in the middle, we're going to use something called the AC method. Look at A and look at C. We notice that A is 3 and C is 14. 3 and 14 together multiplied will give me 52, I do believe. 42. So I'm going to look at factors of 42. That will give me my middle number. So I need factors of A and C that will give me B. Okay, so 42, I'm looking for factors of 42 that will give me 1 when subtracted. So let's start thinking of factors of 42. 1 and 42, 2 and 21. Any others? Three and 14, that one's obvious. What other factors of 42 are there? 6 and 7. Okay, now I'm looking at for difference, right? Different sign difference. So the difference between 1 and 42 is 41. The difference between 2 and 21 is 19. The difference between 3 and 14 is 11. And the difference between 6 and 7 is 1. So which one is going to give us B? 6 and 7. So this guy's the winner. Okay, so keeping in mind our factors of A were only 3 and 1. I'm looking at a combination of A and B that will give me A and C. I'm looking at combinations of A and C that will give me AC together. So I have 3 and 1, and I'm going to look over here. Neither one of those will give me, look at 1 and 14 and 3 and 1 combined. That will not give me 6 and 7. So that one's out. 3, 1, and 2 and 7 will give me 6 and 7. Notice 3 times 2 is 6. 1 times 7 is 7. Okay, so I know that my 3 is going to have to multiply by a 2. So when I do my foiling, 3 is going to multiply by 2. And my other factor was 7. So 7 is going to multiply by 1. This is all equaling 0. Next, I just solved these for 0 because there's a property. This is factoring, by the way. There's a property that of 0 that says that if something multiplied together is 0, then one of the factors of it must be 0. Okay? So this is just factoring is all we did. Factor it. Then I set each of them. Now this is a separate problem. This is the end of my proof. Right here is the end of my proof. But now I have to answer the question because I've got back into solving. So I need to set each of these equal to 0. So 3x plus 7 equals 0. And I need to solve it. So I subtract 7 on both sides. Subtract 7 on both sides. And I get 3x equals negative 7. Divide by 3. X equals negative 7 thirds. Now if I wrote that as a decimal, it'd be harder to write. So I'm just going to leave it as negative 7 thirds. Next part, x minus 2 equals 0. I'm going to add 2 to both sides. I'm going to get x equals positive 2. And now these are my two answers. I have two answers and I have to figure out which one of them works. So looking back at my original equation, if my x is a negative number, look what my width will be. It will be a negative number. So looking at this answer, it won't work because you can't have a negative length on your width. When I look at my x is equal to 2, that one will work because it won't give me a negative length. So my actual answer is 100% only x equaling 2. So now I have to answer the real question, which was what are the dimensions? So my length was 3 multiplied by x, which is going to be 2 plus 1. So I have 6 plus 1, which is just 7. Then my width, which is 2 multiplied by x, which is 2, and that is 4. So I need to establish my side length dimensions, 7 foot and 4 foot.